Hello, calculus fans. Let's talk about implicit differentiation using partial derivatives. So let's find dz by dy, and what we'll do is we'll assume that z is defined implicitly as a function of x and y by this equation. Remember that the whole purpose behind implicit differentiation is that you might have an equation that defines a relationship between some variables, but you can't solve for the variable that you're interested in. So in this equation, you could try to solve for z, but you probably wouldn't be very successful. So in order to find dz by dy, we're going to differentiate implicitly with respect to y. And when we do that, we'll pretend that x is a constant. So the first term that we differentiate, which is x cubed, that disappears. The next term we differentiate, 3xy, we're differentiating with respect to y, so it becomes 3x. This term turns into this. Next, we'll differentiate z to the fourth. That turns into 4z cubed times dz by dy. The dz by dy is there because of the chain rule. On the right side, we're going to need the product rule to differentiate 5xyz. Think of 5xyz as being grouped 5xy times z. And so the product rule and the chain rule tells us that 5xyz, when we differentiate with respect to y, we'll get 5xy times the derivative of z plus 5x times z. Now we're going to just solve for dz by dy algebraically. If we solve for dz by dy, we'll end up with 5xz minus 3x all over 4z cubed minus 5xy. We're just solving for this algebraically. Okay, that's all for now.